Awesome, thank you. Hello, I'm super excited to be here in Raleigh. It's my first time here and it's beautiful. So today I'll be talking about how your reliability priorities evolve as your organization grows and how to keep your product and engineering teams on the same page. So who am I? My name is Xin Tai and I'm a product manager at Datadog working to build collaborative service management tools. In my day-to-day, I spend a lot of time talking to SREs about the processes they have in place to monitor and improve service health. I also dabble in a little bit of technical writing. I spent about 3 years before this role writing about things like containers, serverless, and zero trust. And I enjoy going to local cafes, so if there are any cool ones in the area, I could always use a third cup of coffee. All right, so it's been incredibly interesting being a part of a hypergrowth company. For anyone unfamiliar, Datadog is an observability and security platform for modern environments. And just 5 years ago, we were a far smaller company. Our platform centered around our core infrastructure monitoring, logging, and tracing solutions. But since then, we've grown to 19 product verticals. Today, we operate at massive scale. We run across multiple clouds and process tens of trillions of events daily. And along this journey, we've built, torn down, and rebuilt systems, teams, and processes. And we're always figuring out how to figure out new ways to operate and work together. So my talk today aims to highlight some of the things I've seen work at Datadog, as well as some of the other companies I've spoken to. Right. So product managers and engineers have quite an interesting relationship. As a product manager myself, my goal is always to get features out the door as quickly as possible, gather feedback, figure out what works, and repeat that over and over again. That is arguably easier when you're an early stage startup. You're working with a smaller set of users and services, and you're really only focused on innovating. You're not necessarily concerned about things like scalability or resilience. Those are really things you come back to if you're still here in a year. That, however, starts to change as your organization matures. The conversation slowly evolves to, can we ship feature XYZ by next sprint, to how do we take a feature that a couple people love and serve 10x or 100x the number of users? And how do we do that in a way that is safe and isn't going to cause huge outages? It's also likely that you've accumulated some tech debt. And when that reaches that inflection point where debt actually causes a tangible effect on your product usability or delivery speed, the way you spend your time starts to change. While you were once pushing out new features all the time, you're now having to spend more time on operations. And people tend to talk about tech debt like it's some sort of like grave oversight. But it isn't inherently bad, right? In some cases, there are conscious decisions to optimize for the present, the now, than the future. And in other times, they're a reflection of our understandings of our systems at a particular point in the past. So to digress a little, if you think about the ideal amount of debt that you want to have over time, it sort of approximates to a bell curve. Teams generally take on some sum of debt at the early stages to quickly grow and shape the product. But you should cap its accumulation once you find product market fit. And start paying it down as you scale, because accumulating too much of it can become a drag and prevent you from easily building new things. So going back to what we were discussing before, you're now not only forced to shift away from development, but by nature of the increasing complexity of your environment, you're also likely going to have more outages and more support tickets as you figure out how to put in processes to deal with the changes that come with scale. And it's easy to freak out about these things because they can feel like they're spinning out of control. But having more incidents simply means that things are changing, which should be the case if your company is growing. It doesn't actually mean that you were worse off than before. It is the severity of incidents that gets management nervous, because unavailability now actually means something more significant to users. You serve a wider customer base, you have a reputation in the market, and you don't want to make it more difficult for your sales team. So when OKR season rolls around, it starts getting a little contentious. When you have unreliable services and all of this tech debt to pay down, but also all of these new features that you've already promised to users, how do you then come to consensus on what you should work on? It is relatively simple to measure the impact of product work, as they tie directly to metrics that the business cares about, like customer growth and revenue. It is much harder to reason about investments in reliability. So let's talk a little more about reliability. At a high level, reliability is your customer's perception of the level of service you're providing and whether they can trust your platform to work when they need it to. While you can measure things like availability, your customers ultimately decide whether you're reliable or not. Secondly, reliability is expensive, and efforts to increase it often result in increased complexity. There's going to be more infrastructure to manage, more tooling, and also more engineering hours and money spent. On the flip side, the cost of not investing in reliability is also expensive. Higher severity incidents mean more customer SLAs are breached and more credits needing to be issued. This is why growing companies invest in core SRE teams to work on the biggest organization-wide operational challenges. SREs think about how to take a tech stack, a process, a team structure, and make it work for the next 5 or 10 or so years. And by driving initiatives at a macro level, individual teams don't have to reinvent the wheel every time they encounter a similar problem. And if effective, the number of SREs should scale sublinearly with the number of services you have, allowing individual teams to operate more efficiently. So we've taken some of the top-level systemic reliability concerns out of the pictures that's taken care by your core SRE teams. But there's still all of this stuff your engineering team wants to do to address the problems you're facing with your own services today. There's some combination of things to reduce the risk of outages, like conducting operational reviews, load testing, and game days. Things to limit the blast radius of issues, like sharding and better tenant isolation. And also things to reduce the mean time to detect and remediate with better monitoring and automated rollbacks. And while all of this is good things to do, the reality is that most product managers and engineers don't discuss what it means for a product to be successful in the same way. They care about different metrics, which makes it difficult to come to consensus on what to prioritize. So one way the industry has gotten cross-functional teams to discuss feature and reliability trade-offs within the same context is with the service level objectives model. SLOs provide a framework for defining what matters to customers and setting clear targets around those things to help you deliver a consistent experience. You can also think of SLOs as an approximation of customer trust and whether they'll keep coming back to you. So for example, if you're a ride-sharing app and users can load the page to book a car, that's clearly pretty bad. And if that happens 2 days in a row or 3 days in a row, no one's going to want to use your app anymore. So in an SLO, once you define a target, say 99.9%, what remains, which is the 1%, the 0.1%, becomes your error budget. This is allowable downtime, and it acts as a guardrail to prevent you from taking on too much risk. SLOs began as a way for back-end teams to measure the reliability of their microservices, but they're also increasingly popular among front-end teams, as well as platform teams providing infrastructure like Kubernetes and Kafka. Another common misconception is that SLOs is simply a reporting tool. You probably publish it once at the end of the month and forget about it. But reliability should not be a property of the architecture of a system, but also the mindset of the people who built it. And what is really compelling about the process of setting up SLOs, which I think is often overlooked, is that it forces you to think about your changing systems. Things like, do you even have the data to measure different aspects of your end user experience? Do you have a good understanding of your application's boundaries? What are your downstream dependencies, and are they serving your data correctly? And who do you depend on, and what is their promised reliability? Are you depending on a service that is less reliable than what you require? So when you set SLOs on user journeys and the components that power them, you now have a way to figure out exactly where problems lie and how they impact the end user experience. Additionally, SLOs make trade-offs explicit, especially when we're talking about business metrics like revenue, margins, ROI, cost savings. They can, for instance, help you assess whether downscaling or downsizing, reducing your infrastructure spend will still allow you to meet your customers' needs. And since SLOs track performance indicators that real users care about, we now have a basis for making decisions around what to prioritize. So in this next section, we'll go over a strategy that you can use to then drive organizational alignment. So first, you'll want to start by ensuring all of your services have SLOs. When I talk to people, one of the most common questions I get is, what is the easiest way to get SLOs for all of my services? And to that, I always recommend offering organization-wide golden paths. It's really difficult for all of your teams to start from nowhere. So if you can provide top-level guidance on things like service tiering, the types of SLOs that should be created, so saying things like every gRPC service should have an availability and latency SLO, and third, standard metrics and latency thresholds that you can use, whether these metrics are from load balancers, proxies, service meshes, or custom metrics. You now have a consistent way to roll out these baseline SLOs while keeping it flexible enough that individual teams can then fine-tune and target either specific endpoints or specific parts of the service that they feel are most important. And a good practice is to create SLOs as part of your production readiness or feature release process. This makes reliability proactive rather than reactive. And as you release newer versions of your feature, you can then look back and track regressions. This way, engineering teams can then loop in their PMs to figure out what we should do when your services do start degrading. How do you display errors? How do you load data? Should you load data slower? And things like that to handle degradations. SLOs are also a good starting point if you're looking to mature your SRE practice and establish more streamlined processes. And that is because in any large-scale SLO rollout, you're typically tracking these three goals. Do all of my services have SLOs? Are we in compliance with our objectives? And how do we actually hit those objectives? The answer to the first question is by tracking all of your SLOs in one place. This lets you easily see which services have SLOs and which ones don't. The second necessitates defining clear service owners because you need a single team to own a single objective. Because when your SLOs are burning, you need to know who to engage to fix the problem. And third, how do we actually ensure we hit those objectives? That requires understanding what's causing your SLOs to trend in a certain way. And you need additional service telemetry to do that. This means that efforts to establish SLOs and centralize your service health information generally go hand in hand. So once you have SLOs, the next step is to identify problematic aspects of your service. Because in order to actually configure these, you need to understand your failure domains and what that means for your availability. And to illustrate what I mean, let's just go over a simple example. So say I have a service, call it service A, and it has an X% chance of failing. What happens if I chain 3 of these together, where all of them are hard dependencies and they each have an X% chance of failing? What's the probability that the whole application goes down? Well, it's about this, whatever this formula is, but it's actually 3 times higher than it was before when you only had a single service. And of course, this is a vast oversimplification. real-world architectures are not this simple, but basically what I'm trying to convey is that the impact of dependencies on overall availability is not additive, it's multiplicative. So things can get really awful really quickly if you don't have mitigations in place. You can also look at cloud regions and availability zones in the same way. So if the likelihood that an availability zone goes down is Y%, for an entire region to go down, all 3 availability zones will have to be down. So what if we put the first case and the second case together? How does this look? Well, it's not great, because previously, while each availability zone felt independently, we've now introduced dependencies across them. So now any availability zone going down means an entire failure of our system. So the takeaway here is that dependencies can increase your failure domain, so you need to know when they exist. Now, what if we changed it to this? Is this better or worse? Now you have separate applications in different availability zones. It is, in fact, better. Now we have applications that are isolated from each other, but replicated across availability zones to reduce single points of failure. So the conclusion here is that you should consider your failure domains and the blast radius of issues. This will allow us to better understand our availability, set appropriate SLOs, and decide how to go about improving reliability. Because if you need to be a 3.9 service, but you have a hard dependency on a 2.9 service, you need to put in mitigations to account for this. Next, alerts can also give you a good idea of how frequently a problem is occurring, but no one likes being paged at 3 a.m. for an alert to then auto-resolve after a couple of seconds. Traditional static alerts can be incredibly noisy if it fluctuates at the threshold, right? So this is an arbitrary threshold that I pick, and it's alerting me a lot. And the risk of having a lot of alerts that look this way is that it's difficult to distinguish real problems from ones that are not important. Because as we all know, when everything's important, nothing is important. Instead, paging on SLO burn rate means you're only paging for real sustained problems that impact real users. These alerts evaluate over 2 windows, so when you do get alerted, you know that it's a problem that occurred in the recent past and is still ongoing right now. Burn rates are also not only interesting when they detect fast burn, when things are like deteriorating really quickly right now, but also slow burns are sometimes even more interesting because they surface regressions that are difficult to detect, and typically traditional monitoring mechanisms don't easily pick up. And I think a lot of the time when I talk to teams that get paged too often, it's often that they're paged on degradations that don't even matter to customers, which is why I always encourage teams to start every incident or operational review with SLOs rather than looking at your alerts or your pages, and then asking your product managers what level of performance is acceptable to users so that you can then focus on what is actually important. Now, you'll want to analyze how your SLOs are trending to better understand what problems customers are facing. Once you have all your SLOs, you can ask questions like, are some services always breaching their SLOs? Are my burn rate alerts always going off? And are issues disproportionately affecting one customer, or is it spread evenly across my entire customer base? And this is important to understand because during an incident response, a page that is broken for 100,000 customers requires a different level of response than when it stops working for a single customer. Another popular pattern is aggregating SLOs to a level that captures the health of an entire application and paying attention to that only. And while that is useful for getting it down to a manageable number of indicators, I will caution that this does actually hide the severity of issues. So sometimes you might have low traffic endpoints that serve your most important requests that then get drowned out by high traffic ones serving your less important requests. So it's just something to be wary about. All right, so now that you understand which part of your application needs work, you'll want to assess the risk of these issues. For each risk, you'll want to estimate the likelihood of it happening. Is something going to crash tomorrow or in a month, in a year, and what sort of impact would it cause for your business? You'll want to note down things that appear in the top right corner and the red corner, things that are high risk and frequently occurring. And if you have a lot of these, it's likely that you have some very unhappy customers because you're trying to put out one fire after another, you're treading water, and it's difficult to get out of the situation. So you'll want to figure out what that means for you and how to then move out of this area. And for the things that are not in red, you want to continue monitoring the situation and assess if and when this might become a bigger risk in the future. Think about how much you're investing right now to maintain it at the green level and what would happen if you were to scale back your investments. This now gives you an idea of which problems you might want to tackle first that you can then turn into a reliability roadmap. You'll want to figure out whether you can address this in a phased manner, such as by employing mitigations and short-term fixes before working on longer-term improvements. And ultimately, your goal is to move out of that danger zone by incrementally decreasing the impact of issues and the frequency at which it occurs. And you can then reference this roadmap in your OKR discussions. This now facilitates a two-way conversation between product managers and engineers as reliability work is now tied to business outcomes. Having a more defined scope and timeline for reliability work also helps product managers understand which features will get shipped and which ones won't, and whether that will be acceptable from a business standpoint. You can also find opportunities to fold tech debt together with current product work. So for instance, by including the cost of refactoring a piece of code that is used by a feature that you're building right now, it's a lot easier to negotiate like a timeline extension than a full refactoring project. Lastly, you'll want to measure the impact of your work on your SLOs. So say if you had an incident at some point and you put in a new reliability mechanism, like some automation in place, you should run a game day and maybe even give it some time to test in production to confirm that actually worked. You'll want to see how it moves your SLOs and then figure out next steps from there. So to conclude, what are some key takeaways from this talk? Firstly, how fast you can build features is a function of your reliability, and your SRE practices will have to mature as your company grows. Secondly, SLOs at the end of the day are just one part of SRE. What they do is create a dialogue between different stakeholders about quality and reliability. And this dialogue happens in the same language. Because I think when we work in silos, all too often we get bogged down in the technical details and in our own work that it becomes difficult to communicate in a way that everybody actually understands. What SLOs do is they create common terminology to communicate how software and systems are performing and how reliable they are. And most importantly, SLOs place focus on what customers actually care about. Third, establish organization-wide golden paths. It helps teams get up and running faster, and you should think about setting up SLOs as part of your feature release process. Today, there are lots of tools that help you with this. Terraform is one of them, but there are also other infrastructure as code tools that you can leverage. Fourth, using SLOs as a guide, figure out your reliability roadmap for the next 1 month, 6 months, and 12 months. Figure out what requires your urgent attention and assess that trade-off against features that you won't be able to deliver. And fifth, Last but not least, measure progress by tracking the impact of your reliability work on your SLOs. Then tie that back to business goals and ensure you're moving in the right direction. This will create better collaboration between product managers and engineers. So that concludes it. Thank you so much, and I'll be around if you want to talk about SLOs or dogs. This is Colin, and here's my LinkedIn. Yep. Thank you so much.
All right. That was an awesome talk. Thank you so much. One more round of applause.